Hello, welcome to our Me102B project. We are lab rats, and our project name is Botanical Buddy. So, what Botanical Buddy is, it's here to help you be a better plant parent. So, the motivation behind this is that we want to build a robotic system that ensures proper sun exposure for houseplants. And you might be wondering why even work on this, but we realize that plants can have sudden growth and more susceptibility to pests and diseases if they're not properly taken care of. So what Botanical Buddy does, it provides shade and shelter if the sun exposure is too high, as well as a rotational aspect to ensure an even distribution of sun exposure. Now for the next part, for actuators and sensors, we have two different ones. So the first set are a pair of light sensors that are connected to the microcontroller that receive an analog input that are able to control the Lazy Susan microwave rotational aspect that we have. And then the next part is the two brush DC motors that we're using. So as I mentioned before, we already have a rotational aspect going on that's controlled by one motor, and the second one controls a translational aspect.
The subassembly that we are most proud of is the linear transmission, which is intended to reduce the axial forces on the motor, moving the box in the linear direction. This is with the use of flexible shaft coupler, ball bearings, and a Belleville washer.
So here we're going to see the smart plant pot in action. And the first thing that's going to take place is the plant pot rotating to maintain an even distribution of light. So you're going to see rotations from all four corners of the pot, P1, P2, P3, and P4, based off of the light sensor inputs. And we're exacerbating the disparity by shining a light or flashlight into the right-hand side. And so the way this is working is by calculating which corner of the plant pot has the lowest amount of light and then rotating to that pot every 10, or that's position every 10 seconds.
And now it's rotating, or it's translating to the other side of, let's say we put a windowsill on half of this, and then it would translate so that it would move out of the windowsill, so it would move out of the sunlight. And that's when you've reached a certain threshold of sunlight for all corners of the plant, and then it would move out. And then the next morning, say we would move this plant back into the sunlight to restart the whole process. We also have this plant pot driven by velocity driven position control, which is in the next video. We have where if you try to move it, it'll move back to our desired position. And now we have a happy plant.